This is the second video in deductive geometry, and today we're going to deal with polygons. So what is a polygon? So a polygon is a shape with many sides, a shape with n sides, and that n needs to be greater than 3. So a very simple polygon would be a triangle. Cannot draw a one-sided polygon because that's just a point. Two-sided polygon is just a line segment. Okay, that's an oxymoron. No such thing as a two-sided polygon. So for polygons, then n must be greater than or equal to 3, and polygons can be regular or irregular. So this could be a regular polygon where all sides and angles are the same, or irregular, well, all sides and angles are not the same. So that is a scalene triangle. So triangles are polygons. So here it gives a slightly different definition. Polygons are two-dimensional shapes. They're made of straight lines, and the shape is closed. All the lines add up. So the third diagram there is not a polygon. So polygons are two-dimensional shapes. They're made of straight lines, and the shape is closed. That means all the lines add up. So here we've got some examples of polygons. We're not allowed to have curves, and the shape cannot be open. So polygon comes from the Greek language. Poly means many, and gon means angle. Okay, so let's move on. So the types of polygons, like triangles, isosceles, scalene, and equilateral, we can define the types of polygons that we have. We've already done irregular and regular, concave and convex. Well, convex means that all the vertices point outwards. Concave means that the one of the vertices points in. So a convex polygon has no angles pointing outwards, inwards. More precisely, no internal angle can be more than 180 degrees. If any angle is greater than 180, the polygon is concave. Think concave has a cave in it. Okay, so let's move on. So we can define polygons. We've got triangle, quadrilateral, pentagon, hexagon, heptagon. Some countries call it a seven-sided shape a septagon. So here we have internal angle. Now we know that the internal angle of these are regular polygons. That means all the angles and the sides are the same. So we've got a list there. Now this is where it gets a little bit complicated. So we are going to have a very close look at internal and external angles. Now we're just about to go on to proofs in the next video. So I want to do a proof for the sum of interior angles, the proof for one external angle in a regular polygon, and the proof for an exterior angle. Okay, so let's have a look at this really good video I found. Yes, we would want media player. Okay, so this gives a visual proof. At least it did. Let's have a look. Okay, so can we see? Let's pause the video. So these are external angles. They're external angles. And if we shrink the external angles down, we eventually arrive at a point. So this will be a visual proof that exterior angles always sum to 360. Okay, so let's get rid of that. So let's take a closer look then at the sum of internal angles. So I'm going to do that in. Okay, so proof, sum of internal angles is equal to, so I'm going to use I for internal angles, is equal to 180 n minus 1 divided by n. Okay, so we're going to prove that, and that this is why your teachers have always told you that we need to show all the steps in our calculations, because sometimes questions start at the answer and ask you to show how we've arrived at the answer. Okay, so I'm going to redraw this, and I'm going to say I'm going to connect all these. Okay, these are not very good. Okay, so we've got angles there. Now, I want you to imagine that we've got one triangle, two triangles, three triangles, and we keep on going, 4 triangles to get n triangles. Okay, so we have got 180 n triangles. That is the sum of angles in all the triangles of this polygon. So let me just explain that again. We've split this n-sided polygon. Okay, this is vertex 1, vertex 2, vertex 3, vertex 4, and we're going to keep on going, and we're going to say we've got n vertices. So this is where the 180n comes from. There's 180 degrees in one triangle. If we have n triangles, the sum of those angles is going to be 180n. So let's go through what we've added up here. We've added up this, this, and this for every triangle. But we want the internal angles or the interior angles. So what do you think we need to subtract? We only want these angles here. But we've added on this one here. So if we go around all the shape, we've found that we've added 360. So we need to subtract 360. We can factorize this. So now we're left with, this is the sum of internal angles. The sum of internal angles is 180 n minus 2. So one internal angle, by definition then, we divide by n. So Q, E, D. Okay, so I hope you understood that. So let's have a go at doing the sum of exterior angles. And by the previous diagram, we know that the sum is going to be 360. Okay, let's get rid of this mess. Okay, this is one of my favorite proofs in geometry. It's beautiful. It's a beautiful proof. Okay, again, we're going to say that we have one vertex, two vertexes, three vertexes, four vertexes, and we're going to keep on going to n vertices. Okay, so I'm going to give this a title. So proof that the sum of exterior angles in a polygon is equal to 360. This is a beautiful proof. Okay, so we've got sum exterior angles is equal to 360. Okay, so let's start this off. So we've got 180 multiplied by n straight lines. So we got one straight line, two straight lines, three straight lines, four straight lines, and five straight lines. Okay, now see if you can go further and find out what we need to do next. So we've got this in all the shapes. But we don't want the sum of all that angle. We need to subtract the internal angles. So let's do that. We know the formula for the external angle is 180 n minus 2. So let's expand this binomial. So we've got 180n plus 360. We can cancel this out. And then we are just left with 360 degrees. Okay, that's a beautiful proof. So let's have a look at some questions. So pause the video and see if you can do these questions. Okay, so hopefully you've done that now. It says find the size of each interior angle. So this is a pentagon. So the interior angle formula is 180 n minus 2 all divided by n. Okay, so another way to do this is to say, well, we can just draw triangles. We know that it has 5 vertices. 1, 2, 3, 4, 5. And in any pentagon, the number of triangles versus the number of vertices is always subtract 2. So for example, a triangle, we know the vertex is 3. The triangle is 3 minus 2, which is 1. Got one triangle here. Put another polygon. We have 1 vertex, 2 vertex, 3 vertex, 4 vertex. So vertices are 4. Number of triangles is 4 minus 2, which is 2. 1 triangle, 2 triangles. Okay, so pause the video and have a go at these 2 questions. Okay, so hopefully you've done that now. Pause the video. So let's have a go at doing this. So we've got 180. We've got 5 minus 2 all divided by 5. So that just gives us 180 multiplied by 3 divided by 5, which gives 180 degrees. Okay, so the second question says 3 identical regular pentagons are drawn above. Work out the size of angle Y. So we know that this is 108, this is 108, this is 108. So let's set up our equation. We've got 3 times 108 degrees plus y is equal to 360. So we know that y is equal to 360. Subtract 3 lots of 108. which is 36. Okay, so pause the video. This is a beautiful question. Pause the video and see if you can have a go doing this question. Okay, so we need to work out the one internal angle here. So the internal angle, the formula is 180 n minus 2 divided by n. So we've got 180, it's a hexagon, which is 6, divided by 6. So we've got internal angle is 120. So this is just a isosceles triangle. So we know that this is 120. So these are going to be equal. So this is going to be x, x for the definition of isosceles triangle. So we have 2x plus 120 is equal to 180. So we've got x is equal to 30 degrees. 180 minus 120, 60 divided by 2 is 30. Nice question. Okay, we're making really good progress. Okay, shown below is a regular hexagon with an interior angle which is labeled y. Okay, so work out the size of each exterior angle. So exterior angle formula, the sum of angles is 360 divided by n. So we've got 360 divided by hex is 6. So we've got 60 degrees. Nice and easy. And we can check to see if that's right by multiplying 60 by 6, which gives 360. Okay, so calculate the size of A or B. So A or B is this. Now, these are all, because it's regular, these are all going to be congruent triangles. So that is the same as splitting. We've got 1 angle, 2 angles, 3 angles, 4 angles, 5 angles, 6 angles, 7 angles, 8 angles. So angle AOB is 360 divided by 8. It's 45. And we need to find the angle ABC. So we need to find one internal angle of a regular octagon. So one internal angle is going to be 180. 8 minus 2 divided by 8. Which is 135. Now, the angle here is bisected. It's bisected, so we need to divide that by 2 angle ABC. So if we were to find one of these angles there, they would we need to divide 135 by 2, but ABC is this angle all the way across there. So that's just 135. shown below is an interior angle from a regular polygon. Calculate the number of sides the polygon has. Okay, so we know internal angle is equal to 180 n minus 2 all divided by n. So we've got 175 degrees is equal to 180 n minus 2 all over n. So we multiply both sides by n. So the next line we have 175n. That goes. So we can add 360 to both sides and subtract 175n from both sides. And we are left with 360 is equal to 5n. So we've got n divided by 5 both sides, and we have 360 divided by 5, which gives 72. Okay, so there's not right here. What's going on? So is it interior angle from a regular polygon? I agree with that, I agree with that. So we've got the expansion 360. Okay, this is right. Wow, that's pretty amazing. We can check to see if that's right by doing internal angle 180 degrees, 75 minus 2 divided by 75. So we've got 180 times 73 divided by 75 is indeed 175. Okay, so, and there's an alternative way to do that. We could say, well, this is a 5-degree external angle. So we've got external angle, remember, one of them is 360 divided by n. So we got an external angle of 5. So that gives 72. Okay. And that is the end of the video. And who would know that a 75 sided shape has an internal angle of 175? Okay, brilliant. Keep up the good work, and I hope you're enjoying deductive geometry.